Mass spectroscopy. This is going to be very important in determining the molecular weight of our compounds and to determining the molecular formula of the compounds. To perform mass spec, the compound is vaporized. Here our sample is here. We heat it up with the heater to vaporize it, and then we ionize it with an electron beam. That means we charge it. We make it charged. And when we do this, we break it into pieces. The pieces then are accelerated and sent through a magnetic field right here, where they are deflected. Larger molecules are deflected less than smaller molecules, and so the cations that we made are separated based on their mass to charge ratio, and it produces a mass spectrum that's going to look something like this. This largest peak in this case is always the base peak, and it's assigned a value of 100%. Now in this case, the base peak is also the molecular peak. Okay? And that molecular peak gives us our molar mass. In this particular case, we've got methane. Our molar mass of methane is going to be 16. And so that mark at 16 is the ionized methane. It's got a positive charge on it. It's knocked off an electron. The peak next to it, the peak here at 15, is a methane that's had a hydrogen knocked off of it. The peak at 14 has lost 2 hydrogens, the peak at 13 has lost 3 hydrogens, and the peak at 12 has lost all 4 hydrogens and is just a carbon. And you can see those here, here, and here. We want to analyze this peak. It's one of the most important peaks because it gives us the molar mass. If we have a compound like benzene with a molar mass of 78, this is very resistant to being broken up, and so this is our molecular peak is the same as our base peak. If we look at something like pentane, though, its molar mass is 72. We find that this is the molecular peak and this is the base peak, because it is more liable to be fragmented, and so we get a different base peak. All right, so we can tell what the molar mass is. That is important on 2 things. One, just knowing the molar mass will help us determine whether there are double or triple bonds in our compound. If the molar mass is an odd number, then nitrogen must be present in an odd number. You have to have an odd number of nitrogens. And so that can help us also to determine the formulas. So how would you distinguish between each pair of compounds using mass spec? Well, the compound on the left has an oxygen, so it's going to have 2 more. Compound on left is going to have a molar mass that's +2. And here, the compound on the right is going to be +1. So the molar mass of this is 78. the molar mass of the compound with nitrogen is 79. So just by knowing the molar mass, we're able to start to figure out the molecular formulas. So here we can use the nitrogen rule to determine whether the molecular weight should be even or should be odd. Here it will be even because there are no nitrogens. Here it is also even because there are no nitrogens. Here it will be odd because there is a nitrogen. Here it will be even because there are 2 nitrogens. And you can actually figure out, take the time and figure out the molecular weight of each of these compounds, and you'll find that this will work.